Hi guys, this is a video to accompany the laboratory assignment. In this video I'm going to go through a couple of simple things to help you get started in performing your analyses. In order to complete the laboratory assignment there are two things that you need, both of which can be downloaded from Husky CT. The first thing you need is the Word document which has the title PT 5430 Laboratory Assignment 2020. And if you carefully read through this, you should understand exactly what the requirements of the laboratory assignment are going to be. The second thing that you will need is an Excel file called Dataset for Gait and Posture Analysis _ lab student version. When you open the Excel file, you'll either see this in front of you or this in front of you, depending upon what tab you click on. So we can see there's two tabs. One has some gait data, and one has some data recorded from some postural control or someone standing on a force plate. When you do your analysis, you're going to want to click on gait data, and here's the data set that you're actually going to be working with. One thing that you might recognize when you're looking at this data is that this is the exact type of data that we went through in Lecture 5. So if we go over to Lecture 5, at the beginning of the lecture, we went through what it means to understand the kinds of data that gets collected by a motion capture system. So when you're starting to do this assignment, if this is not fresh in your mind, I would go back to this lecture and rewatch this part in terms of because this lecture will teach you how to understand what's going on in the dataset. The other thing that's important in Lecture 5 is as you go through the lecture, there will be information about the different angles that we'll be talking about in the assignment, and more importantly, there will be information on the specific ways that you would want to go about calculating those angles. These particular slides that we've got here are going to be remarkably useful in performing this assignment. So if you reach a point that when you're looking at one of the questions and you don't know how to go about answering that question, go and have a look through these slides. The answer to how to do it is likely to be sitting inside this lecture. So if we return back up to this slide here, we can actually get it to go onto that slide. There we go. Going through this slide will show you how to get yourself oriented to the data in the dataset. So here we see the data in the dataset. Here we have frame number here, and here we have the positions for particular coordinates: x coordinate, y coordinate for the base of the rib cage, x coordinate, y coordinate for the right hip, and up here we have information about frame rate. So this gives you the basics that you'd need to get the basic information you'd need to get started following the procedures that are outlined in the lecture. Now, in order to get you oriented to using Excel, I'm not going to do this assignment for you, but what I am going to do is show you how we would do what we've done on this slide here in Excel. So in order to do this, let's take our data here with our frame number and our position, and then let's put that in Excel. So here we have our frame and our position into Excel. We know that our frame rate is equal to 4 Hertz, and we know our frame period, going through the calculations, ended up being 0.25 seconds. What does this mean? This means that there is a difference in 0.25 seconds in between each of these frames. So if we assume that frame 3 starts at 0.75 seconds, Yes, that's what we assumed. So frame 3 is at 0.75 seconds. So this one's going to be 0.75. Actually, let's give this a title, time. Let's make it bold for aesthetic purposes. Now, what we want to do, and a trick that we can use in Excel, is if we want to increment time by 0.25 as we go down, we can click in the cell below and we can hit the equals button. We can then click on the cell that we want to do something to, and then we can do put plus 0.25. So what I have done here, I'm going to make this wider so it's easier to see, is we've created a formula in Excel to calculate something. Let's go through this again. So to start a formula, you click into the cell, you hit the equal sign, and then our formula wants to be the value that's in this cell. So if I click on this cell, it's going to say equals D3. So if we see we're in column D, row 3. So it's going to say it's going to be equal the value D3 plus 0.25. I hit enter. Now, if I wanted to, I could now go equals the previous value plus 0.25, and then that would give us the next time series value. Alternatively, we can use a nice feature in Excel where if we have a formula, we can drag that formula down and it will automatically extend that formula through the cells. So if I click on this one, we can actually see the formula up here. So we've got the value of this cell equals the value of D4, which is in the cell just above, plus 0.25. And so we end up getting our time variable calculated. There's one last way that we could have done this. So I'll show you that now. I'm going to get rid of the data. We can create a formula that involves the frame. So, for example, if I go equals, and then I come over and hit the frame number. So we're going to create a formula that's saying equals to 3, and we're going to multiply that by 0.25. So we're saying 3 times 0.25, that gives us a 0.75. If I now come up here, you see the little rectangle in the corner there. If I click on that and wait for it to create a little cross, click on it, left click on it, drag down, and I'm going to get time calculated again in exactly the same way, but just using a slightly different method. So having calculated time, we now have a time variable and a position variable. And with these, we have the ability to calculate velocity. So let's go and run through how a velocity would be calculated. So rather than just putting V for velocity, or and let's imagine that x1 is the shoulder, and you were calculating the velocity of the shoulder, you might write V shoulder. Rather than doing that, I'm actually putting the formula for calculating velocity that we took from the lecture. So one thing that you can do that can make your life easier and more organized is if things aren't fitting right in the columns, you can adjust the column widths up here. So here we have our formula for velocity. Velocity equals the change in x divided by the change in time. And the changes that we're interested in is the changes as we go from one frame to the next. So we're interested in the change in time, which will be the amount of time that elapses between two frames that are next to each other, and the change in position. Now, if you remember from the lecture, this formula won't work in this first row here because we don't have a previous time to look at. So we're going to start down here. Let's look at creating this formula. So again, to create a formula, you hit the equals key, and if you remember from the formula that we had, we were putting the different parts of the formula into parentheses. So the first thing that we want to do is we want to calculate the change in time between the current frame, which is on this row here, and the previous frame, which is on this frame. So the current position is 2.3. So if we click here, so we see it says C4, which is this value, and then we're going to subtract from that the previous value of position, which is going to be in C3, which is going to be our value of 0. Okay, so here we have our delta x, our change in position that's occurred across these two frames. Now we want to divide this by the change in time. So we're going to put this in parentheses again to make sure that so you want to do this to make sure that the calculation inside the parentheses happens before the other operations are performed. Okay, so now we're going to look at the change in time. So we want the current time subtract the previous time. Hit enter. We end up with 9.2. Now, the wonderful thing about Excel again, if we hover over this corner box here, click on it, drag down, we end up with 9.2, 140.8, 82.8, and 14, which are the same values that we had in the lecture. The last thing I want to go through is how to create the kinds of graphs that we're looking for in the assignment with Excel. So the first type of graph that we can think of creating would be a graph of how velocity changes over time. So a time series graph of velocity. So let's have a look at how we would go about doing this. Given the way that our data is arranged here, with time and velocity next to each other, if we highlight that data, then we go to Insert, then we go to a particular type of graph called a scattergram, which is going to give us the types of results that we want. And we want to choose a scattergram that's not just dots, but has dots with straight lines between it. If you select that scattergram, you'll end up getting a graph where we have time on the x-axis and velocity on the y-axis. And Excel automatically arranged this graph in this way because we have time and velocity positioned next to each other in our highlighting. Once we've got this, we want to make some minor changes to the graph. So we want to definitely add some axes titles in. So here we have velocity, and that is going to be in millimeters per second, based upon what we said in the lecture. And down here we have time, which is just going to be in seconds. Okay, so that gives us a graph of time versus velocity. One last thing that could be usefully done is, given that we might have more than one time series graph, identifying exactly what's being graphed here. So this is going to be the x1 coordinate, or it's going to be, or in the lecture we said that this was going to be the shoulder. And we could also identify which variable that we're talking about. And from the lecture, the x-coordinate was going to be the anterior posterior direction. So that gives us a graph. Next, I want to talk about how we would create a time series graph of position. Excel is a wonderful tool, but it can be a little bit finicky when it comes to creating graphs. The easiest way for you to create a graph is to arrange your data in a way where you will end up with the type of graph getting automatically created. So this worked out fantastically for when we have time versus velocity, because we have time in the left column and velocity in the right column. But if we want to create a time series graph of time versus position, we'll end up with a graph that isn't formatted correctly. So for example, if I highlight both of these, go insert, add our scattergram, we're going to end up with time on the y-axis, which isn't how a time series graph is supposed to be formatted. So how do we get this to be created? What we need to do is we need to bring our data, we need to take copies of our data and arrange them in a way in separate columns so that the Excel can automatically calculate them. There's some little subtle tricks that are involved in doing this. So let's take time, and we're going to move time over to here. Going to copy time and then come and paste it. It's very important that when you do the paste, you do a particular type of paste called paste values. Because we have formulas, we don't want the formulas to be copied, we want the results of the formulas to be copied. We want the values that are the values that come out of the formula to be moved. So we want to do a paste of values. Okay, so now we have our time. So I'll show you what we've done. If I click on this cell, we can see up here that this equals B3 times 0.25. If I now click on here, because we did a paste values, this just equals 0.75. We basically got rid of the formula. So now we have time as one variable. Now let's go and take our position, and again we're going to paste values. In this case we could actually do a regular paste, but because there's no formulas in there, so as a general rule, it's probably safer to just do paste values. Okay, and equals x1. Let's copy across the formatted version because it looks nicer. Okay, so now we have time in the left column, position in the right column. We now highlight both of these, go into insert, go and find our scattergram with lines on it again, and now we end up with a second graph. So now we can bring this down underneath our velocity graph. Let's add some axes to this, axes titles. So now we have time again in seconds, and here we have the we can put shoulder position in here, and this is going to be in millimeters. So one thing you'll notice is that we have one more data point in this graph than we do in this, because we lost our data point when we calculated velocity. So I've just clicked over to the Excel file that has the data for your analysis in it. I've opened this because the last thing I want to do today is take you through some of the little tips and tricks for working with data that has lots of numbers in it. So here we have the data that you're going to be working on, and in order to illustrate some of the simple tips and tricks, I'm going to do a quick analysis of some of the posture data. So open up the data, we can orient ourselves to the data set. Here we have our sample number, each sample of data that's recorded of this posture data. And as we go across here, we see the different variables that are recorded by the force plates. This is a data set that's analyzing a person standing on a couple of force plates. And so out of this, we can get the ground reaction forces. So Fz is actually our ground reaction force here, and Fx and Fy are our shear forces. You don't need to know this, but I wanted to orient you to this. And over here we have COP variables for where the center of pressure is under the left foot, under the right foot, and averaged across the two. So this is the center of pressure for the x-coordinate and the y-coordinate. The x-coordinate is the medial-lateral direction, and the y-coordinate is the anterior-posterior direction. Okay, let me take you through the first couple of steps of analyzing this. The first thing we want to know is what time is elapsing during this as we move through all of our recorded frames. So the first thing we want to do is calculate a time variable. So how we're going to do this? So we're going to want to take our sample numbers. So I'm going to copy our sample numbers from over here and bring them over here, and then we're going to calculate time. So in order to grab hold of our sample number, I'm going to click at the top. I'm going to come over. I'm going to scroll all the way down to the bottom of the data set. Your data set isn't this long, but here we have 3,500 frames in this recording. Then I hold it. Actually, I'm going to show you this again because I don't think I described that quite right. Okay, so in order to copy this really long time series, click at the top, scroll all the way down to the bottom, hold down the Shift key, and then click at the bottom. Right click, copy that data, and then we can do a paste values and put it in here. Now, just to make life easier, we're going to put a title of what's in here. Actually, so this would be better called frame number, and we can just stretch this column so it fits more nicely. Okay, in order to calculate time, so create the title time, press equals to start writing a formula, and our time that's elapsed is going to equal frame number multiplied by the amount of time that has elapsed. Okay, so what's the amount of time that elapses between each across each frame? Up here we see we have our sampling rate of 100 Hertz. Our sampling period then would be 1 over 100, which would be equal to 0.01 seconds. If I hit enter. Okay, now if I click in this cell, hover over the corner until I get an X, and drag down a few, we see that we get our calculation of time coming down. With a really long time series here, dragging can get a bit annoying, and so we can actually calculate all of the values for this by just double clicking with the left mouse button in the corner. We see it drags down. This only works if you have the relevant data right next to here, so it knows how far down it's going to go. So we have a sampling rate of 100 Hertz. That means 100 samples per second. We know we've calculated things right because if we come down to frame number 100, 1 second has elapsed. Okay, we've calculated a time variable. Let's now think about what it would mean to calculate time versus the x or mediolateral coordinate of the center of pressure. So to do this, let's copy our time variable. So click at the top, come all the way down to the bottom, hold down Shift, then click at the bottom, copy this, and then paste values. So the way I recommend doing this is each time you have a new question to ask, you end up setting up a new set of data in order to perform your analysis and just copy it across. Okay, we're interested in COPX, so we're going to click at the top, going to scroll all the way down to the bottom, and then we're going to click at the bottom, going to copy this, then we're going to do paste values. And because we want it to look nice and organized, we can move the titles around and bold it. Okay, now in order to create this time series, so we're going to, because we've got time on the left and a variable on the right, we're going to get things arranged correctly. If we click on the at the top left, then scroll down all the way to the bottom, hold down the Shift key and click on the bottom right. Oh, actually, I was just about to copy that, then I got into the habit. We don't want to do that. We then want to scroll all the way back up to the top. Now we want to go and insert a scattergram. Scattergram with lines. Actually, in this particular case, I'm not going to have the dots, I'm just going to have the lines, and you'll see why in a second. So let's create that graph, and there we see our 3,500 data points of our center of pressure data. And the reason I didn't create the dots is because the dots would make it harder to see the little variations that are going on here. So Ideally what we should do is put some axes labels on this, but I'm not going to for the moment because I want to move on to the next thing. So the last thing I want to show you is creating graphs where you're just not plotting time versus some variable, you're just wanting to plot one variable versus another. In the case of center of pressure data, plotting the medial-lateral coordinate of center of pressure against the anterior-posterior coordinate of the center of pressure is revealing because it gives you a sense of where the location of pressure underneath your feet is moving around, so you can get a sense of how that's moving in space. Okay, so to do this, let's copy this data for x and y. So I'm going to scroll. So I've clicked at the beginning of the data I want to copy. I'm going to scroll down, and I click at the end of the data I want to copy. So hold down Shift, then click. Copy the data, and then we're going to bring it over here. Again, just going to paste values. Same as before, just to make things look more simple. I'm just going to get rid of the units and just have these titles at the top. Now what I want to do is, if I want to have the x value on the x-axis, I want it in the left column, and so we're arranged appropriately here. So let's click at the top here, scroll all the way down, hold down the Shift key, click, get the data highlighted, scroll back up to the top. If you don't scroll back up to the top, your graph will get created right at the bottom, and it'll start creating it'll create problems in trying to find your graphs. And we're going to go Insert, Scattergram. We're just going to use lines again because we've got so many data points that if we had our dots, it would actually make it difficult to see what was going on. Okay, so let's. 3,500 data points is making Excel a little bit overwhelmed. Okay, now we have our graph. Add some axes titles. So this is going to be center of pressure. Center of pressure in the medial lateral direction, and it's actually going to be in millimeters. And here we've got center of pressure anterior posterior, and this is going to be in millimeters as well. So by choosing the right type of graph, we are able to see our data in a way that's informative about what's going on in the movement. In this particular case here, if you imagine that you're standing up and you're looking down at your feet, the trajectory that we're seeing here is how your center of pressure, the location at which your ground reaction force vector is operating, is changing over time. So this is for a person that's just standing still. You just ask them to stand still, and even when you ask the person to stand still, you see fine postural adjustments where, what are the data we've got? So we're going from -5 millimeters to minus 40 millimeters. So we've got about 300. We've got about 3.5 centimeters of movement. So we're talking about an inch and a half of movement in the anterior posterior direction, and when we're looking in the medial lateral direction, we've got 10. We've got almost 20 millimeters, or about 2 centimeters. So around about an inch of movement in that direction. So if we were to rearrange this so that the units end up being approximately equal, we get a good sense of what kind of movement in the center of pressure that we've got. So hopefully after seeing this video you'll have enough knowledge of how to use Excel in order to perform the laboratory assignment.